Good evening. Tonight I'm going to discuss what the student paired test is and kind of just what it is and when we would use it. So to start, just like the others, you begin with the question, because what are you trying to learn? What's our goal? And of course, this is our third one that's running very similar with all of the steps. So I feel like, of course, it was the easiest because the only thing different was a little bit towards the bottom. We did the eta squared instead of the Cohen's and the R squared. But other than that, it's really almost the same thing as the others. But to get started, after really thinking about this, the meeting tonight, I really should have done, I would be anxious to know actually 4th to 5th grade, because in 3rd grade, it's their first year to ever take the STAR. But then in 4th grade, what I teach, we now have a new subject. So now we don't just have reading and math, now we have writing. So if I was to go back and do this, I would have actually chosen to do grades 4 and going into 5th. Just to see that comparison. Does it make a difference when you're focused just on 2 subjects and then you go to 4th and now you have a whole nother subject, looking at the difference there? But what my mindset was I was thinking 3rd grade, it's brand new, so you kind of have, I don't know if you want to call it excitement, but you kind of have that extra just giddy, like, oh, it's our first year for a STAR. You're a little bit more anxious. And so I wanted to compare and see, is it statistically different, the 2018 raw score to the 2019? Because in 4th grade now, they've already been exposed to the STAR, unless this past year with COVID. Unfortunately, they haven't. So the 4th graders this year will be taking that STAR for the very first time. But regardless, in past, I just wanted to see, 3rd grade, they're going to have those, I guess, just a little bit more nervousness, I feel like, compared to 4th grade because they haven't been through it. So I was just really trying to see, is that statistically different between 2018 for 3rd grade and the 2019 for 4th grade on their reading test? So first thing you need to do, of course, is you want to get rid of all the extra data. And so that way we can examine exactly what we're needing. So I did keep the raw score for 17-18 and the raw score for 18-19. And also it's a little bit hidden, but my grades are right over here. Grades, they were enrolled in 3rd and then went to 4th. Now, something that you do have to add is the difference. And all that simply is I want to subtract the raw score 17-18 from the raw score 18-19 all the way down, because we are going to need that in one of our steps. So that's something that you can do ahead of time because you're going to need it. Also, something else that you have to do right off the bat is you do have to figure out your mean and standard deviation for both. So, of course, we've been doing that the last several modules, but you just take the average of each and then you find the standard deviation. As you can see here are the formulas that you can use that will do the work for you. So after you get this started, it really is time to start. Here is the difference, and here's my difference right here, but here is the formula just for future reference. So once again, my question simply was, I want to know, is there a big difference between 3rd and 4th, with this being their first test, and then moving into 4th, and also 4th grade adds another test. So I just want to see, is there a big difference statistically speaking? Of course, this time we're going to do the paired sample t-test because we want to compare the means of the same participants over a period of time. So that's how it would be paired. We're going to check the assumptions, and as we talked about on our call, it is a little bit different due to what we are sampling. But to start, of course, it's random. The observations, number 2 is different in this case, whereas before it was not dependent on one another. However, this is because I'm tracking the same participants over time. And then, of course, we want to look, are the scores normally distributed? So to get started, of course, here is our box and whiskers, if you want, the box plot that does show. For the most part, it looks very normally distributed, really, a normal distribution. You have a quarter here, about half in here, and a quarter here. However, there are outliers on each end, but if you're looking, they are pretty even. So I feel like that was a pretty normally distributed chart showing that. As we list the hypothesis, of course, rejecting the null or accepting the null. And basically the first one is just saying they're going to be equal. So if they're equal, we're going to fail to reject the null, meaning it's going to be located in here. On the second, where I'm going to reject the null, is where they are going to actually be different. So once again, I'm just trying to see, are they statistically the same or are they statistically different based on analyzing the data using these t-tests? The alpha, once again, is always 0.05 because in education, 95% is good enough. Now, if you were in something else like you spoke about tonight, vaccines or something that really, before you put it out there, you want it to be 99.9999, then you, of course, would want to lower the alpha. So first thing first, we're just going to calculate the statistics. So we need to get a little bit of information. To start, there's 795 participants. This N needs to be equal for both because I am looking at my variable really is the same set of students both ways. So they were in third grade and then they went to fourth grade. So that number needs to be equal. You still do have the degrees of variance, of course, -1, which would leave it at 794. So to find the t-critical, here's the chart. Once again, you just simply look at it. 794 is going to be, of course, infinity and beyond. It's going to be it's a very large number at this point. We're doing a very large sample. So it is actually the very bottom. And here is where I have my 0.05 two-tailed test because I'm looking at it and I'm not saying one is greater or one is less. So it's going to be a two-tailed. So we'll follow that down. So my t-critical is going to be 1.960, and that's where you'll find that. Now, once I get this data, I'm really ready to run and see what the paired sample comes up. Is it going to be different or is it going to be similar? So with that, of course, you just go to your data toolpack and enter your data. Now, your two variables, of course, are just simply going to be the raw score for 1718 and your raw score for 1819. We do not have a dummy data in this one, and the reason being is because I truly have paired data. So I'm not making anything up. My data is paired. Once you get your results, I highlighted some of the critical numbers that we're going to pay a lot of attention to. But like Dr. Cooper, I really prefer the t-stat and the two-tail. I love putting it in the graph. I think that visual just brings it home for me as well. It's very easy to read, very easy to understand. I did not change this number because I do know how to do exponential. And this is just simply saying there's 15 zeros before. And so it is going to be like something like 0.0000000000501,893. So I understand how that works teaching math and science. But for those who don't, then that would be something that they would want to go format so they could see all of those zeros. And we could format it by doing that. As far as our numbers, let's take a look. So the t-critical two-tail is 1.96. So in red, I have marked where that would fall on my graph. As you can see, 1.96, 1.96. So if it was going to fall in here, I could fail to reject the null, meaning that the results, statistically speaking, are very similar. However, in this case, you're going to see the t-statistic shows -7.98. So if I follow this as a line, then actually -7.98 is going to be far to the left. It's going to be out of this area. So we're going to reject the null. Simply put, statistically speaking, that they are not similar, right? If I'm answering my question, then they are not similar. Those mean scores they're different. Now we can continue on to see the effects and how different are they. And this is important to note because if I was truly comparing this on my campus, then I would want to know what happened. Did we decrease or go up, right? By negative, I'm thinking we're decreasing, but I would just need to look at that based on the score. Because if you look here, it looks like we're increasing. So I would just need a little clarification. But either way, if it's this big of a difference, I would want to know why. And we would need to correct it. But once again, the numbers are deceiving because when I look at this, this is only showing me what little 22.1. So a little over 1 point difference in those mean averages. So just if I was to just glance, I would say there's not very much of a difference. But if we run the data, then we are showing a pretty big difference. So we would want to figure that out, and we're going to continue interpreting that to see. So of course, here it is. It just kind of shows we did reject the null because the negative 7.98, right? And actually, I want to fix this because I was reading this earlier, and this would read negative 7.98 is less than negative 1.963. And that is true, actually. That is true, but it gets confusing because you're going to say, well, actually, that number is bigger. But if we're on a number line and we're going negative, or you think about a bank account, no, you're going in the hole further, right? So the further I go in the hole, then that would be correct. This negative 1.963, if I'm only short $2 compared to $8, then that would help make sense to me. So at first I was like, that's not right. That's not right. And I had to keep looking at it to really wrap my mind around why we would put this as our result. So this once again just kind of shows you it, and that's how many variables we had, or that's how many students I had. And then once again, it shows that negative 7.982. Now, we did quite a bit of talking about this today and it being greater or less than the 0.05. And that is kind of where I get tricked up on, because I know if I put 15 zeros in front of this number, if I put 15 zeros and I move my decimal with that, then I know that is actually going to be less. It's going to be way less than 0.05. So it gets a little bit tricky there, but I like you, Dr. Cooper, I really like to focus on this visual because it makes sense to me, and I can explain that. And we all know people learn. Most people are visual learners. You know, when I say a word, you think of the visual, you think of an image. So I think the visual captures more, in essence, what you're trying to get across as your results. So of course it just states it again. The mean for the third grade reading star test, 21.25, was statistically different than the mean of the fourth grade reading star test in 2019. Once again, there's those means, and just by looking, they're deceiving, because I would say, no, that's really not a big difference. And I wouldn't be worried about it until I took this class and really learned that is not a true statement until you do some research. But before this class, I would easily have said, oh, that's not really a big difference. Let's not focus on that. There's probably something else we need to worry about. So, and that's honestly speaking, and I'm sure I'm not the only one. But to kind of find the effect, here it is. Of course, we're not going to do the Cohen's d or the r squared here, but we do have the eta squared, and we have a lot of data that we're going to need. Now, I got these from the shared handouts, and they're a little bit blurry, so I looked at those before I copied them. I'm not too sure I snipped them, but they became blurry. So, but as I look at this, of course, you're just finding your number. There was my t stat. I squared it. And then I have my t squared plus my n minus 1. My n, of course, was a 795. And then minus 1. And there you'll see the numbers as well to get my answer. So here is what I came up with at the end. Because what I did is I found what the squared was, because that's going to be my top number. And I found what the bottom number is, because that's going to be the bottom of my formula of my division problems, so my numerator and denominators. And then I simply just put it in the formula, and here they are. So I'm just dividing the top, so this one divided by that, to get my effect size. As you can see, 0.07 is going to be medium, just barely over medium, 0.06. And it says or 6%, so I'm thinking in that range, 0.06 or 6%, and add 0.07. So I'm slightly above that 0.06, making that a medium effect. Once again, I can clearly tell there's an effect here, and so I would want to do more research to figure out why, especially if these are my campuses that I am overseeing and running the data on. You know, I want to be confident in figuring out what's going on there. And then lastly, we end with the confidence interval again. I know I asked a question about this, and I'll show you in a moment exactly, again, kind of where I was confused. Now, for this confidence interval, you do have to find a little bit more information, and that's this formula right here. So I actually put the square root of n right here because you're going to need that to do this formula. But here was n, here was my square root. Of course, we were given the means. The difference in the scores, you simply just, you have the average of that. So the mean of the difference in scores, that is where I said we would need the difference. And here's my differences. So I am going to find the average And I'm also going to find the standard deviation of those as well. So that's all I did for that. And then this is where the T critical value numbers, and then this is where your formulas come in handy because this is what you have to do. So this is, which M1 minus M2 is E to Z. That's just your mean 1 minus your mean 2. But to find the standard deviation, you do got to do a little bit more math. And you just simply follow the formulas, which is very simple to me. I will just say sometimes I feel like it gets tricky on Excel, and so I like to double check myself either on my phone or a TI-83 or the calculator you can pull up on the internet that has a lot of functions, just to double check that I put parentheses in the right spot if you're going to put it all together. So when we get finished, here is my range, and I love that it's a narrow range. However, that was my question when I was talking to Dr. Cooper tonight of, I love that it's a small range because I know you shared on your example that the smaller the range, the better it is. So I love that it's a very small range. However, my question is, if this is my range, negative 0.99, which is close to negative 1, to negative 1.64, would my t-stat, this negative 7.98, need to fit in this? And that is kind of where I get stuck. I'm not exactly sure. I need to do probably a little bit of research myself on it, because when I'm looking at my previous 2 modules, my first one, it falls right inside that confidence interval. And it almost reminds me, hey, I'm confident. My answer was correct. It matches up. However, these last 2, it hasn't. Now, the good thing is it was negative. My t-stat is negative, and so are these. And my previous module was the same. It was negative, and it was a negative answer. So it tells me I'm in the right direction, but I feel like I'm missing something somewhere because of that first module alluding to it should be in those sets of numbers, because that's what a confidence interval I would think would be. So I'm anxious to see what we find out about that in the future, because I feel like that is something that, of course, before I was to present this to someone, I would want that just clarification, because that's a question. If I have it, I know someone else might be like, well, if that's your confidence interval, then should your t-stat be in there? So hopefully in the future we will find that answer out. But nonetheless, we did answer the question, and that was simply that they are statistically different, and something would need to be done. If this is my campus, something would need to be done. We would need to figure out, and it's just a perfect reminder that numbers can be very deceiving. So I hope this helps me in my future of looking at the data. It's very simple now that I've done it. This is the 3rd time. And then, of course, after our meeting tonight, too, just, the more we do it, the better we get, as we know. So I look forward to the rest of the semester and kind of what we learn next. I have learned so much and had no idea that Excel was capable, or I was capable of, to run data like this. So I look forward to learning more. Thank you.